So yeah, I'm going to talk about synthetic performance testing, and I'm Matt from DebugBear. So yeah, synthetic testing is also called kind of lab testing because you set up this kind of controlled test environment with a certain screen size, a certain browser location, a certain network speed, CPU speed, and then kind of measure performance and collect a lot of in-depth kind of reporting in there. And yes, I'm going to talk about the debug web website speed test. There's a free version of it as well as a kind of monitoring version. And yeah, let's just take a look at what some of the data looks like. So this is kind of like the kind of summary view. You've got the Lighthouse score, you've got some data for view user metrics from Google Crux, as well as a bunch of overall performance metrics. You've got this film strip view that shows you different kind of rendering milestones, kind of when content appears. There's also a video recording version of it, kind of showing you when the visitor comes to a site, what do they experience, and when do different page elements show up. And then we also have some custom performance recommendation for a specific site at the bottom. So the request view is probably what I'm mostly going to talk about because we're looking at the request waterfall. So the waterfall shows you all the requests that are being made when you're loading your website. And yeah, it starts with the HTML code. Then you can see there's a bunch of render blocking CSS files, JavaScript files. And then we can see there's this one. It's the biggest one that takes the longest to kind of download. And then basically after that is downloaded, there's this little CPU task in orange. And then once that happens, we can kind of correlate what's happening on the network and on the CPU with actually what the user can see. So after the render blocking CSS is loaded, that's kind of when page content starts to appear, and yeah, the page starts to render. So yeah, you can kind of see different parts of the request. You can see when the connection is being created, how long that takes. Sometimes you can see there's these dark shaded areas on the request, and that tells you when data is arriving. You can see the different priorities that the browser has assigned to each request, as well as how much data is being transferred. And one of the things we can see here is that the CSS file is quite large. So I'm going to expand this and wait a little bit because it's kind of parsing the CSS code in the browser right now. But basically, the size analysis can tell us what is actually making this file so big. And you can see here it says 62% of the file is actually selectors. So when I expand this first one, for example, you can see it's 16 kilobytes of just kind of selector code. So yeah, basically, if you can optimize that, you have a smaller file that kind of downloads a lot more quickly. And I think another one here, which is not as impactful, is that there's this kind of embedded font, but it's quite a small font, so it's not something to really think about too much. So if I go back to the overview tab, I have this kind of more focused view on specific metrics. So rather than looking at all of my requests, I can just look at the LCP and the requests that are relevant to the large contentful paint on the page. So we can see what image is responsible for the LCP. We can also see one issue, which is kind of a low priority request. The subparts that tell us that the issue is that, first of all, there's a load delay, so the file is not being discovered. And then there's high download duration, which just means it takes some time to actually download the image once the browser knows about it. The LCP image discovery, that is a more filtered or focused version of the request waterfall. And it tells us how the different files related to the LCP image kind of related to each other. So here we can see that the image is not directly loaded from the HTML, but rather there's the CSS file. If I expand this, I can see there's a background image, and that is kind of why the browser doesn't know that it needs to load this image until the page is actually rendered. And the browser is like, I need to style the content on this page, and to do that, I now need the image. So yeah, it kind of shows you this kind of more filtered view, and at the bottom, we have some of these custom performance recommendations. One of these is that you should initiate your LCP image request from the document. And we also have this option to run an experiment. So that basically allows you to change your HTML code and see okay, if we made this change, how would that impact page load time? So in this case, we're just kind of telling the browser to kind of load the main image early on, so there is not this kind of sequential chain of requests. And then, yeah, you can click on Run Experiment, and it will show you a before and after version. Discord is a bit annoying because the actual LCP image is this little dot that is not really visible. So I'm going to switch to like a slightly different example that I ran earlier on the London government kind of homepage. So here you can see once the request is once the experiment is complete, you can see how does that impact performance. If I expand this metric, it tells me, okay, here are this is kind of the before and after view of the request waterfall, and we can see that the LCP image is kind of just loaded a lot earlier, and it's kind of high priority from the start. And yeah, then visually, unlike on the Discord example, we can actually see, okay, this image just loads a lot sooner now that we've made this optimization. So that just means we can try out some of these optimizations and see if they're actually impactful before making those on our live website. Other than that, this is just one more example. This is a Tesco homepage, and some of the nice things that you can see in the waterfall is that they are using something called early hints. So this is like a 103 status code that is returned before the actual document HTML is ready. So the server can tell the browser that it should start loading these two fonts while it's still working on actually figuring out what the HTML looks like. So once the page starts loading, once the rest of the page starts loading, those fonts are ready at that point already. And then, yeah, we can also look at the CSS size. Sometimes it can give us a bunch of kind of embedded SVGs, for example, or in this case, also, a bunch of kind of JSON code that's kind of embedded. So yeah, overall, it's just a lot of kind of suggestions or ways you can analyze performance. Okay, so just talking about some of the internals a bit. There are basically kind of three main data sources that I would think about for website performance data. So the first one are the web APIs. So this is just kind of what you run on the page. This is what the user monitoring tools have access to. Something like performance, like entry spread type. This gives us all the requests and some like request durations. But there are some limitations here. So I can't get any information about kind of iframes on my page, or I can't get the download side of third-party requests just for security and privacy reasons. Then there's the DevTools protocol, which is kind of what Chrome DevTools is based around, which has a lot more detail. I can get like the full response data, all that kind of stuff. And one thing to note is like the web APIs, they're kind of relatively standardized. At least someone has written a specification, even if they're not fully supported in all browsers. The DevTools protocol, I feel like at some point there was an effort to kind of standardize some of these commands across different browsers, but generally a lot of it's kind of a bit custom to each browser. And then finally, we have like Chrome Tray. So this is not really necessarily built to have like any stable, reliable API of kind of, just like widely usable or shared between browsers. It's just kind of Chrome telling us, okay, this is like the time when the HTTP cache was checked, and the HTTP cache, it took like 2 milliseconds or whatever. Like, so we got a lot of really deep internal data about what is happening on the network, on the main thread, in the renderer process, all that kind of stuff. And this one particular type of entry that I want to look at a bit more, which is this computer privacy mode, which in this case is disabled. So that basically means there are two types of kind of requests. There are credentialed requests that kind of include cookies, and then there are kind of uncredentialed requests that don't include them. And this is kind of relevant for web performance because in Chrome and in Firefox, these are not, they cannot be made on the same server connection. So typically, when you have like an example like this, where we have like 2 requests to segment.com, with HTTP2, like we can make a lot of requests on the same connection, even at the same time. And we would expect all those requests to just use the same connection. But because I think analytics, this file is credentialed, but the second file is not, because this is fetch request, that means they cannot use the same connection. You can see that there have to be 2 connections that have to be created when loading this, by making those 2 requests. So yeah, that's like how it works in Firefox. And in Chrome, Edge does allow 2 requests to use the same connection, even if one of them is credentialed and the other is not credentialed. Safari also apparently does something special, but yeah, I don't fully understand it. But this just kind of matters for some kind of cause request. So for example, this is like one of the recommendations that we have where we detect an incorrectly configured kind of pre-connect request. So in this case, it is, I think, made as a uncredentialed request, but actually needs to be a credentialed request. And that's kind of why it's not actually working correctly. So here you can see it has a cross-origin attribute. But even though there's a pre-connect to this origin, the pre-connect can actually not be used. And the browser only makes the connection when it actually knows about the resource as well. And yeah, so this is all kind of applies to pre-connect hints. One of the things that you need the netlog for as well is like Chrome will tell you about all of the requests, but it will not tell you about connections that are not related to a request. And in the example of the Tesco website, you can see it actually properly creates the connection to this other domain name before the actual request is ready. And then once it's needs to make the request, the connection is prepared. And you can also see this is like another example of an early hint because the connection starts being made before the main HTML starts being downloaded. So another thing I want to talk about are request priorities. So each request that the browser makes, you can see the priorities that in the request waterfall. And some of them are going to be low priority. For example, in this case, we just tell the browser with the fetch priority attribute. Some of them are going to be high priority. And depending on that, like that determines like, first of all, how soon the request is going to be made, and also what the browser tells the server about how important it is. So that second part is the HTTP priority. There's this urgency parameter, which is between 0, which is very important, and then 7, which is like not very important. And you can see when that is kind of working correctly, even though the browser kind of receives these 3 requests, it starts serving the important image first. So in the response data, we can see, okay, there's a limited amount of bandwidth, and the server decides, okay, I'm just going to send all the bytes for the main image first. Then I'm going to send this like less important image, and then finally the low priority image that's maybe outside of the viewport. I don't need to bother sending any data for that until everything else on the page is loaded once the connection is kind of idle. So this is an example where that's kind of working really well, but that's not always the case. So not all servers properly support this. So here we can see another example where we have some medium priority requests and a high priority one for the LCP. But the server is kind of just intermingling the data a fair bit. So while we really are waiting for the LCP to happen and to kind of show the main image to the user, the browser is actually busy like sending some additional pretty useless data for the medium priority request that might not even be visible. This is another example. We have all of these low priority requests. So the default priority for an image request in Chrome is always going to be low. But then basically either, for example, you have a fetch priority attribute, or when the browser renders a page and realize, oh, this is actually in the viewport, I need this to kind of display the current page content. There's a change in the request priority from low to high. And that's what you can see in this example. But you can see that's not being honored correctly by the server in this case. And I think it's a Cloudflare side in this case. So Robert Marks and some other people, they did a bunch of research a while ago, kind of comparing different servers and how they're actually handling things. And if you look at Cloudflare, you can see they do not, at least at the time, correctly support reprioritization. So if you tell Cloudflare from the start, okay, this is an important file, it will send it in the right order. If you don't do it and the browser realizes, oh, this is actually more important than I thought it was originally, then it might not give you the right data. And you can see some of them are all supporting it really well, but there's a lot of servers that just don't really do a great job of sending the data in the right way. And for historical reasons, and partly because like the browser doesn't really trust the server to send things in the right order, the browser just decides to not send the request at all if it's worried about not getting the right data. So that is basically called tight mode. So you can see that there's basically 2 load stages. One is the initial set of requests, the high priority ones. And then you can see the gray area is kind of this wait time. So that tells you that Chrome knows about this resource. It knows the page needs this resource, but it doesn't want to send the request yet until the page is kind of exits tight mode, which is like this initial loading phase. And yeah, so basically, there's these 2 phases, tight mode and I guess not tight mode. And basically, tide mode ends when the body is attached to the document. And yeah, both of those topics have like great talks by Robert Marks about them, about both kind of tide mode and how it differs between browsers, as well as like an investigation of like how servers handle resource priorities when sending responses. So the next thing I want to talk about, and that's kind of relevant to how you do synthetic monitoring, is network throttling. So you always kind of tend to run, your test maybe on a computer locally or in like a server, and you probably have a pretty good network connection at that point. But really, you want to test like how fast would this page load on like a mobile connection. So that's kind of why you end up using throttling. And there are different ways to throttle the network. I'm going to look at packet level throttling, dev tool throttling, and simulated throttling. So packet level throttling, it kind of happens at the operating system level. You can hold back each packet for a certain amount of time to add latency. That's what like DebugBear does or what web page test does. And it's generally kind of the most kind of accurate way, but the limitation is that it kind of is annoying because it applies to your entire computer. And also you kind of need admin rights to enable it. So DevTools, it wants to just like throttle certain things in one particular tab. So the way to think of DevTools throttling is really that it's a minimum request duration. So if I set up a 2-second latency here, then the request will take at least 2 seconds. Now, if the TTFB here for this request ends up being 1 second, the throttled request duration is still going to be 2 seconds. And also, DevTools throttling does not have any concept of server connections or round trips. So it just has this minimum request duration concept. Another thing to keep in mind when working with synthetic testing inside of DevTools is that there is this disable cache option. The cache that this is referring to is the HTTP cache. So you might have a connection cache in Chrome as well, and there's an internal net internals option to flush those connections as well. And on your operating system, you also have a DNS cache. So those two things are not impacted by what you do in DevTools. The last thing is Lighthouse simulated throttling. The way Lighthouse works is that it is going to load your page on a fast connection, and then it's going to say, well, I saw that this page took like 2.5 seconds to load on this fast connection, but like if I think about like how much slower the page would be on like a 3G connection, I think would actually take a lot longer than that. So I think this is kind of logged out automatically if you go on PageSpeed Insights, for example, or if you look at the full JSON of your Lighthouse report. There's going to be 2 numbers for each metric. One is the observed value. So that's like 286 milliseconds in this case. And then the simulated value, which is 2.3 seconds. There are some issues with that because sometimes it's not super accurate. We've got a Chrome extension that kind of highlights what those numbers are on inside of PageSpeed Insights. And also, because there are some of these limitations, and there's some cases where Lighthouse just tells you your website is actually slower than it really is, and you implement optimization and you end up getting a worse score. Ivan Akliv has been doing a bit of work recently trying to like fix some of those limitations of the simulation just to get it to be a bit more accurate. Cool. So yeah, I talked about testing. Just want to touch briefly, I guess, on monitoring. So obviously you kind of want to test on a continuous basis so you can kind of see, okay, when is there a regression? So for example, here, you can see the FCP is going up by like 800 milliseconds. So you can kind of get an alert for that. When I click on the first contentful page metric, I've got this option to kind of compare the test results to each other. And when I enable that, you can see there is this kind of new payment button.css on the Iceland website. So adding this new render blocking request is kind of impacting performance in this case. And yeah, so we do synthetic monitoring. We also do real user monitoring, focus on core web vitals. I'm quite proud of like the IMP and long animation frames reporting, which kind of shows you like what is actually slowing down the interactions, what scripts are taking a long time to run, and why they're running. So sometimes a lot of it is just like, global analytics events. Sometimes it's interactions like actually, to the element that you care about. And yeah, so there is like a DebugBear channel we added on Web Performance Slack recently. So if you've got feedback, feel free to post something there. So recently, I think some people mentioned that they had trouble like sharing data, with people who are not part of their team and just want to share a single test result. So that is something that we added recently, just to make it a bit easier for people to collaborate on the platform. And yeah, that's all for me.